Let's find the derivative of a common logarithm. That is a log with a base. Well, actually, this isn't even a common logarithm. This is just a logarithm that is other than a natural logarithm. Common log is log base 10. This problem here is log base 4. But the rule will apply the same for a log base 10 or a log base 4. And we're going to use the rule that the derivative of a logarithm with a base a is 1 divided by x natural logarithm of a, and we have to have the domain x is greater than 0 because we cannot have an argument for a logarithm that is 0 or less. So working on this problem, I want to find that this is y equals y prime would equal 1 divided by x squared natural logarithm of 4, my base. But I'm not just doing x, I have an inside function here which is x squared. So I have to employ the chain rule. So this is going to be multiplied by the derivative of the inside function here, which is 2x. So again, you can kind of see it. I have log base 4 of x squared. So x squared is my argument. That gives me 1 over, well, it's x squared times the logarithm of the base, which is 4. So that's the bottom part right there. But I have an inside function of x squared, so I have to take the derivative of that using because of the chain rule, and that's the 2x here. So now it's just a matter of simplifying, and that gives me, well, it gives me 2x divided by x squared log 4, and I can simplify that to be 2 divided by x log 4. And that's my answer. And I have to continue with my domain of x is greater than 0. Let's continue with a slightly more complicated problem, but I'm going to use the same rule here. I'm going to use my same log of base a is equal to 1 over x natural logarithm of a, and x has to be greater than 0. So I'm looking at this. I'm going to change this function. I'm going to change it so that it's the same as it is log base 2x to the negative 1. Easier for me to do that, and then I can use the power rule instead of having to use the quotient rule. So this is going to equal, well, negative 1 times log 2x to the negative 2. That takes care of my outside function, but I need to multiply it by the derivative of the inside function. Well, the derivative of log base 2x would be 1 over x natural logarithm of 2. That's using this rule right here. So I generally like to simplify and get rid of negative exponents. So I would have this is equal to, well, this is equal to negative 1 divided by log base 2x squared, taking this piece here and putting it under the denominator, times 1 over x natural logarithm of 2. So I think I would just rewrite that as one single fraction, and I would call it negative 1 divided by x. I like to bring the x to the front. And then it really doesn't matter what order you put these in. Log base 2x squared ln 2. And that is the derivative, and x has to be greater than 0. And you can kind of see that x has to be greater than 0, not only because in our original problem we cannot have a logarithm with an argument of 0 or less, but also now in my derivative, if x was 0, my denominator here would be 0, and that wouldn't work either.